Welcome to the Math Center. Today we're going to review an example of partial fraction decomposition. So let's take our rational function, and notice the denominator is already factored. Now let's look at how the decomposition would go. We have these three denominators, so I need to decompose this using these denominators. So let's see how that would go. Okay, so since this is a linear term, we'll have this as some constant a plus. We have another linear term in the denominator. That'll be some unknown constant b. Now, since this is an irreducible quadratic term here, we will write this as c t. T is our variable here, ct plus d. And I don't need the parentheses in the denominator. Okay, so that's how we will write the decomposition. And now the coefficients, these unknown constants, a, b, c, and d, there are four of them. Those are what we're trying to determine. Okay, so now the next step that's classically done is to find what we call the numerator equation. So if we were to get a common denominator on the right-hand side, and then equate the numerators, we get basically, some people call it the basic equation, or it's the process that's attributable to heave side. I think technically heave side is involving just purely linear terms. But anyway, let's get the numerator equation and we'll see how it goes. Let's see how it goes. Okay, so now if I get a common denominator and equate the numerators, I will get the following. Now you can work through this algebraically, if you like. You can pause the video. So now in the numerator equation, and you can pause the video and work this out, this is what you would get. And as I'm writing this, you leave everything in the factored form. You don't want to waste your time multiplying things out, because all you really care about is determining the coefficients a, b, c, and d. Okay. So if you're wondering where this comes from, or you need the time to work it out, that's great. Just pause the video, try it yourself, and you should get the same result. All right, now technically, this is the kind of the method here that's, now we're looking at a polynomial, and the idea is, even though the original problem, we know that t cannot be the number 2, nor can t be the number -1/2, we're going to still use those in here to evaluate the polynomial here, but really what we're doing is taking the limit. So in a pure mathematical sense, we should be evaluating the limit, but the limit will be achieved by functional evaluation, or plugging in, as we say. So I'm just going to evaluate or plug in t equal 2 and t equal -1/2. Those are the nice numbers that we will use. And then, of course, we have 4 coefficients to determine, so we need 4 values to plug in this technique. So let's just do some nice ones, 0, and let's say 1. But these are the ones that will produce a result much more quickly, as you'll see. Okay, now evaluating this entire equation at 2 would give us, let's evaluate here, 2 times 2, or 2 squared is 4, 4 times 25 is 100, 100 minus 25 is 75. Now this is the beauty of it here. What's 2 minus 2? That's 0. So this whole term is going to go to 0, and because of this one, this whole term is going to go to 0. So we just are left with one term remaining, and of course that will give us b right out of the gate. So this would give us b times 5 times 5, which is 25. So here we have 75 is 25b. So what's b equal to? Divide both sides by 25. b is equal to 3. Okay, and let's highlight these so we can see them in the context of all the work that we're going to do. All right, let's try t equal -1/2. And again, pause the video. I'm going to do the arithmetic mentally. Negative 1/2 squared is 1/4. So here you have 25 times 1/4 minus 25, which should be negative 3/4 times 25. Okay, now once again, let's think ahead. Well, the reason we chose negative 1/2 because this term is 0. So these two terms will go to 0 because this one because of this guy. These will go to 0. So again, we'll get A right out of the gate to simple solving. So here we should get what's negative 1/2 minus 2 more. That's negative 5/2. Okay, so I said negative 5/2. And again, I'm not showing this. I'm doing this. You can do this at your leisure. Plug in the negative 1/2 here. Negative 1/2 squared is 1/4. 1/4 plus 1 is 5/4. So let's see what we have. We have negative 3 times 25 over 4 is equal to negative 25. That's 5 times 5. And what's 2 times 4? That's just 8. And if you multiply both sides by the reciprocal, which is an 8 over negative 25, you will get that A is 6. A nice value. Again, I like to highlight these as we do it so that they'll stand out. Now, t equals 0 is a nice number to evaluate, where it's not going to be as nice as the other two in terms of zeroing out terms. Remember, we're evaluating into this expression. And now, I know what A is, and I know what B is, so watch. I'm going to save time. I'm going to plug that in for these two on the fly. Save myself one little step. If you get confused by that, again, pause the video, slow it down, and work it out yourself so you can see what I'm doing. Well, first, let's just plug in 0. So the left-hand side is just negative 25. Actually, I'll write it out. Watch. I'll do it and then erase it. Okay, so that's A times what? Well, what's 0 minus 2? That's negative 2. And then what's 0 squared plus 1? That's just 1. But look, I know what A is. A is 6. So instead of writing A and completing all of this and then plugging it in on the next step, it's not a lot to write, but we can save ourselves one step there. And if you want, we can just say, okay, we can remind ourselves that was the A. Okay, let's keep going. Plus, I'll do the same thing. We have a B. Now I'm evaluating here, so I'm plugging in 0. 2t, or 2 times 0 plus 1 is 1. And 0 squared plus 1 is 1. Now again, I know B. What's B equal to? 3. So instead of writing this all out, and again, evaluating, recopying everything just to put in place of the B, I'm going to do it right there. Again, just for y'all, I'm just reminding you that's B is 3. Now, C and D we don't know, and that's what these two equations will give us, the C and D. So let's keep going. Now here, what's C times 0 is just 0, so this goes away. And now I'll just have D. That's what I'm going to solve for. And 2 times 0 plus 1 is 1 again, and then 0 minus 2 is negative 2. Okay, so let's see what we have. This is negative 12 plus 3, that's negative 9. Let's add 9 to both sides. So negative 25 plus 9 is negative 16. And this is negative 2d. So what do we get when we solve this? D equal 8. So see, now we have A, B, and D. So now we'll use t equal 1, our last random number. They're not random, really. I chose them nice. You could choose the square root of 17, but that would not be a friendly number to use for anyone. All right, so here we're going to evaluate or plug in the 1. 25 times 1 squared is 25. 25 minus 25 is 0. And I'm going to do the same thing with the a, b, and the c. So now I'm going to go ahead and prep it. What's a? A is 6. We already found that out. So I'm right here in the evaluation. So I'm plugging in 1. 1 minus negative 2. Correction, 1 minus 2 is negative 1. And then here, 1 squared plus 1 is 2. B we already know is 3. So I'm over here, but I'm evaluating here at 1. 2 times 1 plus 1 is 3. 1 squared plus 1 is 2. So I should have 3 times 2. And again, if you like to keep kind of track, we can do that. All right, D we know. So what's D? D is 8. A correction. Let's look at where we are. This is C times T plus D. All right, so C we don't know. That's in fact the last constant to be determined, which is what I'm working on now. C times 1 plus D. D is 8. And I'm over here. Now I'm plugging in 1 again, so I should get another 3 and a negative 1. And let's see what this gives us. This gives us 0 is equal to negative 12 plus 18. What's 3 times negative 1? Negative 3, so let's distribute that. That'll be negative 24 times 3c. Negative 3c, rather. Let's do the simple arithmetic. What's 18 minus 12? That's 6. 6 minus 24 is negative 18. So we get, add 18 to both sides. So we get negative 3c is 18. And what does this say? Of course, this says that c is equal to negative 6. All right, now, by the way, this was all algebra. This is not the calculus involved. So now what we're doing is we're sacrificing our time, however much time that took. We're sacrificing our time to do this algebraic decomposition. It's called partial fraction decomposition. Why? Because each of these integrals, so the integral of this is the integral of this. Of course, we have your dt's there, but that's kind of not really the point of my illustration. And then these are going to be three very easy, technically 4. You have 1, you'll separate these. So you get 1 difficult integral will resolve itself into 4 easy integrals. So let's see. Let's take our equation and see what we have. Okay, now let's go ahead and set it up with the fact that we know that we're integrating. So we have the integral here. And I've just now determined my constants or my coefficients. All right, so let's see. So that's the integral of this. What was a? Let's look back. A is 6. And you can write the d, it's a matter of style. You can write the dt in the numerator, or you can write it out to the side. Those are stylistic variants. They're in essence the same thing. So we're going to separate this. We have the integral. Now what was b equal to? I see it right there, it's 3. And all I'm doing is putting in the values for what I just solved for. Okay, so now let's do this last piece. And c was what? Negative 6. So negative 6. Now don't forget I had the t there with the c, plus the d, which is 8. And I'll put the dt out at the end here, just a little different. The reason we typically write it out here, because you'd have to have parentheses if you put it in the numerator, and that's not wrong, but notice I did the same thing there, if that makes sense. Okay, so now, just to finish it, all right, now this one we're going to separate out into 2 integrals. Why? Because it's 2 different techniques. So here, I'll wait and do these, and I've already done separate videos for these, so link to the video, I'll go straight to the answer. You can watch the other video if you want to integrate that. So in this one, we need to separate it out. It'll be 6t over t squared plus 1. And for room, I'll write the dt in the numerator. So that was this piece here. And then the other piece, which is the 8, I'll write over there. So as I said earlier, it'll be 4 integrals. And here we have the 8 dt. Okay, and so now this one will be a natural log piece. This will be a natural log. This one will also be a natural log. And this last one will be an arctan. And again, I have those videos. I should be able to link them to this one in a way that makes it easy. All right, so let's write down the answer. This will be 3. And again, you can pause the video, work it out yourself. Say the next equality line's up there. Okay, so that's our next step. So it's 3 times the natural log of 2, absolute value of 2t plus 1, plus 3 times the natural log of the absolute value of t minus 2, minus 3 the absolute net times the natural log. Now we have the absolute value, but they'll be removed, and you can watch that video to see why we're able to remove the absolute values there. And finally, the one that's a little different, the arctan. And some of y'all may write tan with the superscript -1, writing it as tan inverse that way, and that's fine. And this is the answer to our partial fraction decomposition. Now again, I'm passing the results of these, the evaluation of those 4 integrals to the other video. So just watch that again. You should be pausing the video whenever you watch these kinds of instructive videos. Pause the video, try to do the work yourself, and you should be able to get that same answer, hopefully. And if not, then click on those other videos. I have all these worked out separately in turn. And we have the final answer, and this is the essence of partial fraction decomposition. What was the hard part? If you watch those videos, it's not these. These go by within a minute or so, even if you're a little bit rusty on those techniques. The hard or the part or the lion's share of this computation is purely algebraic. It's in determining the coefficient. So that's a nice sacrifice. If you're up at the calculus 2 level, which is here, above calculus 1, which is here. So here we have calculus 2, let's say calc 2. And that's predicated on our calculus 1 knowledge. And of course you have pre-calculus and trig. But below that is algebra. So down here at the bottom is your algebraic skills. And that's really where we were. So here we sacrificed taking a problem that was very hard in its form for a calculus 2 problem and converted it into the work, which was all done at a very low level, well, comparatively, right, speaking, lower level, namely at the level of Algebra 2. So once again, I'm Professor Sever. I hope you enjoyed this video. We'll see you next time.